Hi, welcome back to AT Math. Today, 9.4, transforming quadratic functions. Why is easier than playing a video game? Okay, today what we're going to do is we're going to measure how parabolas get their shapes. And what I mean by that is take y equals x squared. Now you figure if you have 0 squared, that's 0. 1 square is 1, 2 square is 4, 3 square is 9. But if you look at the graph, you'll notice, okay, 0, 0, 1, 1, 2, 4, 3, 9. Look how sharp the line turns upwards as the numbers get larger. And the reason for that is as you're squaring larger numbers, they get even larger. So what you'll have is a case where they rise up fairly quickly. Notice that y values rise faster once it passes x equals 1, which is true. Now take a look at this. You have y equals x squared. So again, 0, 0, 1, 1, 2, 2, 2, 4, 3, 9. Notice that is general shape, and notice 2x squared as it's shooting faster. And now take a look at these guys. Notice how the angles turn upward sharper as y is double for each one. Now why is that? Because times 2 means it's going up twice as fast. It's increasing twice as fast. And now we have y equals x squared again, y equals 2x squared, and these guys are showing an even sharper increase when I have 3x squared and 4x squared. Notice how they're cutting even faster than the 2x squared. The bigger the coefficient, the sharper the angle becomes. So the larger the number, quicker the increase upwards. The reverse is true as well. Take y equals x squared, which is basically I tried to make a shape like this, and take y equals 1/5 x squared. 1/5 simply slows down the growth. Will it grow eventually? Yes, it will eventually turn into a parabola, but 1/5 is slowing it down at first, so it's a much slower increase over time. Bigger coefficient, more narrow the parabola. Smaller the coefficient, the wider it is. Now this too. Take a look at 6x squared. You have right here a pretty fast-moving parabola. Now it doesn't look very sharp, but that's because I've gone by 4s here, gone by 8s actually, and the across is only like 0.1, 0.2, 0.3. So I did that to show you an increase that will happen over time. And as time goes on, even with this compressed graph, what you will have is going to eventually shoot up. Now the negative 6x squared is the same way. Simply instead of going up, is going down. That's all. Positive goes up, negative goes down. Now if you're trying to order the functions from narrowest to widest, order the function from narrowest to widest, here's your choices. Negative 2x squared, g of x is 1/3 x squared, h of x is 4x squared. Just take the absolute value of each. In other words, I don't care that it's negative 2. It simply has a value of 2 as far as how it's formed. And the 1/3 x is going to be a slower growth, and the 4x is going to be a quick increase. So 2x squared versus 1/3 x squared versus 4x squared. Narrowest is the largest number, so go from biggest to smallest. In other words, this is the most narrow. That comes second. This comes third. And you can follow that on page 614. It goes with the same thing, saying negative 2, just find out the absolute value is 2. 1/3, the absolute value is also 1/3, and the absolute value of 4 is 4. Therefore, they'll show you from narrowest to widest, 4x squared is the narrowest, followed by negative 2x squared, followed by 1/3 x squared, as you can see here. You try. Put these in order from narrowest graph to widest. Again, same idea. So go ahead and try to find the absolute value and pick the largest absolute value first. Go ahead. Okay. See here I have 4x, 6x, and 0.2x insofar as my absolute values. And I put the 6x squared first because it would be the sharpest, followed by the negative 4x squared, followed by the 0.2x squared, which is much less wide. Quick break. And back. Now just like we learned in 5.9, f of x equals 3x, g of x equals 3x minus 4, h of x equals 3x plus 4. What's the difference between the two? If f of x is 3x, it's going through 0, 0, up 3 over 1, up 3 over 1. But if g of x is 3x minus 4, you do the same thing, but you're pushing it down 4 spaces. And in that same way, if you have f of x, if h of x is 3x plus 4, you're lifting it up 4 spaces. Take a look here. Notice how f of x is sitting right here, and the only difference between h of x is 4 above each one. So no matter where a point on f of x is, h of x is simply simply 4 more than that. Think of a brother or sister that's 4 years older than you. And when you're 20, they're 24. When you're 30, they'd be 34. When you were 10, they were 14, etc. And the same way with the minus 4, same idea. No matter where f of x is, g of x is simply 4 less than. Therefore, from the original line, f of x would translate up 4, and from the original h of x is down 4. Actually, let me reverse that. I'm sorry, because that would be h of x, and this is f of x, because if you notice, not f of x, excuse me, g of x. What I mean is that h of x is translated 4 up from the original, and g of x is translated down 4. So we'll say that for posterity, and drop it down here. Now we do the same with x squared, quadratic equations. F of x equals x squared is your normal parabola. And then you have x squared plus 3, same parabola, just lift it up 3, and it's the same basic shape. Even though this doesn't look the same, this looks like it's narrower, it's not. If you took this and actually dropped it down, it should actually fit. Well, it would if I could make the parabolas correct. You get the idea. It's where it's supposed to be. So, f of x equals x squared, and f of x equals x squared plus 3. Notice that the only difference between the two is that they're 3 above the other one. G of x is simply translated 3 up from f of x. Now take f of x equals x squared. Let's compare it to g of x equals negative 2x squared minus 3. So the three things I want to know is whether the g of x is wider or narrower than f of x, then whether the new parabola opens up or down versus the old one, and whether the g of x is up or down than f of x. Let's take a look. First of all, I compare x squared versus negative 2x squared. So here's x squared, here's negative 2x squared. The absolute value is that the negative 2x squared is a sharper decrease. Since the 2 is bigger than 1, the parabola becomes more narrow. And f of x equals x squared, g of x equals negative 2x squared minus 3. Instead of opening up, it's going to open down. So you think it's going to be skinnier, it's going to go down instead of up. And finally, so the new parabola opens reverse from the old one. And finally, this one starts at 0, 0, where this one starts 3 down. And goes a quick drop like that. So the new parabola is 3 lower than the original. Now you try. Take f of x equals 4x squared plus 2, and you're going to compare it with g of x, which is the new one, negative 2/5 x squared minus 5. Question 1, is it going to be skinnier or wider than the first one? Is it going up or down versus the other one? And where is it going to be on the y-intercept? So go ahead and try. Let's see how you did. Basically, g of x is wider than f of x. Why? Because 4x squared is a pretty sharp increase. Negative 2/5 x is a slow decrease. Secondly, g of x opens downward instead of upward because it's negative instead of positive. And finally, g of x is 7 down from f of x. Why? Because f of x started at plus 2 and g of x started at negative 5, so it's a ways down. Finally, gravity is negative 16x squared. You know that because we talked about it many times. So let's drop an object 64 feet in the air. The question becomes, how long will it take to hit the ground? All you have to put is y equals negative 16x squared plus 64. Negative 16x squared is the gravity, and 64 we say is our height. How do you solve? Well, y is going to equal 0, as before. Then, instead of plus 64, we're going to minus 64. Minus 64 to one side, minus 64 to the other. So now you have negative 64 equals negative 16x squared. Then, to get x squared by itself, instead of times negative 16, divide negative 16. Divide negative 16 on one side, divide on the other. Negative 64 divided by negative 16 will be positive 4. And this cancels, leaving just x squared. Remember, 4 equals x squared, root. And you really get plus and minus 2 equals x. However, in this case here, you are not going to be able to drop an object for negative 2 seconds. Therefore, we can rule out the negative, so it takes 2 seconds to hit the ground. You try, go ahead. Gravity, negative 16x squared, drop an object 144 feet. When will it hit the ground? Go ahead. Let's see how you did. Did you take 0 equals negative 16x squared plus 144? Then minus 144 to both sides. Now divide both sides by negative 16. You get a 9. Root. You're going to get positive negative 3. Negative 3 doesn't work, so only positive 3 seconds. And we are done. Thanks again. See you next time. Bye.